So, welcome to my channel. Rajiv here from Mathvybes, and today we'll be looking at the AdMaths 2024 paper 2 in detail, like proper thing. We're gonna be looking at this from start to finish. The video might be a little 3 hours long, but all the solutions will be very, very in-depth. So stay with me and let we begin. So the first question, they want me to determine the other linear factors of that polynomial there. Real things to say, right? Given that x minus 2 is a factor. So the polynomial we're dealing with is x cubed, right? The highest power is 3, which means it's a cubic equation. Now, since the highest power is 3, fun fact, that's the amount of factors we should have. We should have 3 factors. Depending on the number, the highest power of x, that tells you the amount of factors. So like x squared, for instance. If I had a quadratic, I would have 2 linear factors. If I had x to the power 4, I would have 4 linear factors, whatever the case is. So we're looking for 3 linear factors, right? Now they give us a factor already. They're giving us x minus 2. So since they want me to find the other linear factors and they gave us a factor already, all we have to do is polynomial long division. And then, well, from there we might have a factorize. So let's begin. So I'm gonna write back 3x cubed plus 8x squared minus 20x minus 16. Right? When doing polynomial long division, these are the steps you must follow. So I'm gonna ask myself, what do I have to multiply by x to get back 3x cubed? Well, the answer is 3x squared. Right? Because x squared by x is x cubed, and well, 3 by 1 is 3. So bam. The next thing, you're going to take this and multiply it by all of the terms on the outside. So 3x squared by x is 3x cubed. Then 3x squared by minus 2 is minus 6x squared. Right? The next step is minusing. Get a minus. So 3x cubed minus 3x cubed is 0. And now watch this part carefully here. 8x squared minus 6x squared. Now I know some are already jumping the fence saying, hey, like 2x squared, but no. Relax. It's not 2x squared. And that's because of this minus sign on the outside. Alright, so watch. This is 8x squared minus 6x squared. What I mean is that I have a minus by a minus. A minus by a minus is a plus. So it really means 8x squared plus 6x squared, which is actually 14x squared, right? So I have 14x squared here. Right, the next step, I bring down the other term in a polynomial. So I bring down the minus 20x, right? And asking myself the same question from the start. What am I going to multiply by x to get back 14x squared? Well, to get back 14, I had to write back the 14. And to get back x squared, I gotta put x here, because x by x will give me back the x squared, right? Then I'm taking the 14x and I'm multiplying it by everything over here again. So 14x by x, that's 14x squared. 14x by minus 2, that will give me minus 28x, because a positive by a negative is a negative. Right, then I'm gonna subtract. So 14x squared minus 14x squared is 0. Bam. Then we have minus 20x minus 28. So watch this. Is that kind of chin up scene here? But don't get chin up. Right? Look at what's going on. We have minus 20x and we have minus. So a minus by a minus is a plus. Right? So we have minus 20x plus 28. Since the positive number is bigger, my final answer will be a positive number. So my final answer is just 8x, right? Alright, so over here will be 8x. And well, my last step, I had to bring down back the other term in the polynomial. So minus 16. And I'm going to ask myself, what I had to multiply by x to get 8x? The answer is just 8. Alright? So 8 by x is 8x. 8 by minus 2 is minus 16, and from here just minus again, right? So 8x minus 8x is 0, and well, minus 16 minus minus 16, that will work out to be minus 16 plus 16, which is just 0. Right? So bam. If you didn't get 0 here, pressure in the camp. You was doing something wrong. But since it gets 0, we okay. Because they said that x minus 2 was a factor. If something is a factor, you can divide perfectly without leaving a remainder. So my remainder is 0, that checks out. So, now that I have the quotient here, 3x squared plus 14x plus 8, all I have to do now is just factorize that to get my other two linear factors. Right? This over here, this is a quadratic, so it will give me 2 linear factors. Alright, so I'm going to factorize that now. So, to get x squared, that means I have to multiply x by x. So I'm going to open up 2 big pair of brackets. Alright, I'm going to open up 2 big pair of brackets like so. Right, now to get 3x squared, I'd have to multiply 3x by x. Right, so this is a method I teach my students. I mean, I know it's a the AC method and thing, but this is like from the AC method, but not so complicated. So your first step is to look at the first term. To get the first term, like 3x by x. The second step, you're gonna look at your last term. My last term is 8. To get 8, that'll be 4 by 2, right? So I want to get 14x in the middle. I want to get 14x. So I would put the positive 4 over here, and I would put the positive 2 over there. Reason for that is because the 3x would multiply out like that, so I'm going to put 3x squared plus 12x, and then I go add it on to the 2x over here, and that's how I'll get my 14x, and my 2 by 4 is 8. So that's it there. So my other two factors are 3x plus 2 and x plus 4. And like I told you guys from the start, since we have a cubic, I am expecting 3 linear factors. So my 3 linear factors are x minus 2, 3x plus 2, and x plus 4. Right? Bam. And that's the answer to the first question. So in part 2, they want me to simplify the multiplication. Right? Now before we get scared and thing, relax. It'll be okay. From the first question, to get back the polynomial, we can multiply the quotient by the dividend. It's sounding real complicated, but watch this. Imagine you was dividing 20 by 4, right guys? 20 by 4. 5 by 4 is 20. Well, the remainder will be 0 because we know 4 is a factor of 20. And in dividing 20 by 4, we got 5. 5 is also a factor of 20. That's the same situation we have here. And now, if you multiply 4 by 5, you'll get back the 20. So if I want to get back the 3x cubed plus 8x squared, whatever, I'll multiply this by this. And that's what I'm going to use for the next question, right? So the next question, you see this whole thing on top here? Look how I'm going to write it. I'm going to write it as x minus 2 by this whole thing over here, right? And instead of writing this whole thing over here, I'm going to write this instead, because that's in a more simplified state. So I'm going to write 3x plus 2 by x plus 4, right? And if I were to expand this back out, I'll get back the cubic. Notice we have x by x by x. We have 3x, so that'll be x cubed, right? So that works out there. All over x squared minus 4. I could just write x squared minus 4. Right, multiply by x plus 2 all over x plus 4. So right off the bat, this x plus 4 cancel off with this x plus 4, right? And have some more stuff we could do. I want to draw you guys' attention to the denominator. In the denominator, we have x squared minus 4. X squared minus 4. Another way I could write that is x squared minus 2 squared. If you notice, that's a difference of 2 squares. That is in the form a squared minus b squared. So I could write it as, well, a plus b by a minus b. So in other words, this over here, that will be equal to x minus 2 by x plus 2 or vice versa. Fun fact, it doesn't matter what order you arrange it in, you'll get the same thing, because multiplication is commutative. If I had 7 by 5, that's the same thing as 5 by 7, right? So it don't matter what order you write it in. So if there's a question you had, it clear up now. So I'm gonna write back everything and simplify further. So I didn't cancel off the x minus 2, so I'm gonna write it back. I didn't cancel off the 3x plus 2, so I'm gonna write it back. I did cancel off the x plus 4, so I'm not gonna write it back. And like I said, x squared minus 4, that's the same thing as x minus 2 by x plus 2. And I'm going to multiply that by x plus 2. Right? Since the x plus 4 was cancelled off, I don't have to write it there. So let me see what's going on now. Well, this x minus 2 will cancel off with this x minus 2. And this x plus 2 would cancel off with this x plus 2 on top. So all in all, we end up with 3x plus 2. And that's my answer. My answer is 3x plus 2. Bam. And that's it for the first two questions. So in the first part, you have to do polynomial long division, right? Just a bit of advice, anytime they're asking you to figure out the other linear factors or factorize completely, you have to do polynomial long division, right? And well, in part 2, we had to utilize the fact that 3x cubed plus 8x squared plus minus 20x minus 16, or whatever then. That whole thing will be equal to x minus 2 by 3x squared plus 14x plus 8. And well, you also had to keep in mind that 3x squared plus 14x plus 8 was equal to 3x plus 2 by x plus 4. From that point on, I just had to put it in, cancel off, and simplify further. You would have had to know difference of two squares for this, right? So that is that. That's it for the first questions there. Let me look at part B now. So they're giving us our equation kx squared plus x minus 15 is equal to 10, and they're saying it has roots alpha and beta, where k is an element of the whole number, or the whole number system. So part 1, determine the expressions for alpha plus beta and alpha beta. So first and foremost, I'm going to write back that kx squared plus x minus 15 is equal to 10. I had to write that in the form ax squared plus bx plus c before I do anything. Right, so I had to put it in the form ax squared plus bx plus c is equal to 0. If you notice, guys, it's not equal to 0. What I mean is we got to sum across that 10. Right, we got to sum across that 10. And if you do that, we're going to end up with, get some space. This is what we're going to end up with. So kx squared plus x minus 15, and since I'm moving across the 10 to get 0, the sign will change, so it will now become minus 10, and well, that will be equal to 0 now, because I take everything from the right hand side and I carry it across. So now we don't have anything on the right hand side, right? Let me just simplify it. So I have kx squared plus x, and I have minus 15 minus 10. Minus 15 minus 10, that's minus 25. Right, and that's equal to 0. So now we could pull out what a, b, and c is. So a would be equal to k, b would be equal to 1 because x is the same as 1x, and well, the coefficient of 1x is just 1, right? And the coefficient for c is minus 25. So now we could go ahead and find for stuff. So alpha plus beta. Alpha plus beta is given by minus b over a. Right, and alpha beta is given by c over a. So now that I have b, I could actually work. So I put my minus sign here, right? B is 1 and a is k. Right, so alpha plus beta, that would just simplify to minus 1 over k. Bam. Now we have to deal with alpha beta. Alpha beta is c over a. Right, so c is minus 25, and well, a is k. So that's just minus 25 over k. We can't really simplify that further. Right, so let me just finalize and write the answers. So alpha plus beta was equal to minus 1 over k, And well, alpha beta was equal to minus 25 over k. So in part 2 now, they're saying that alpha squared plus beta squared is equal to 61 over 4. And they want me to use the expressions in B part 1 to determine the value of k. Now this question a bit problematic, and you will see why. So they're saying that alpha squared plus beta squared is equal to 61 over 4. Right? Alpha squared plus beta squared is equal to 61 over 4. Alright. Now, before we could proceed, you had to know what alpha squared plus beta squared is equal to. Alpha squared plus beta squared, that's actually equal to alpha plus beta squared, all squared, minus 2 alpha beta. Right? If you forget any exam, I'm going to show you now how to come up with it. So, first of all guys, alpha squared plus beta squared is not the same thing as alpha plus beta squared. Don't get tired. It's not the same thing. Two different things. However, you could expand this to make this the subject of the formula. You can see what I mean. So imagine you had alpha plus beta squared. That will be equal to alpha plus beta by alpha plus beta. Right, you expand it using your binomial expansion, alpha by alpha, alpha by beta, beta by alpha, right, and then beta by beta again. So, and I'm just showing you guys this in the event that you forget it in the exam and you had to come up with it. So alpha by alpha is alpha squared, alpha by beta is alpha beta, beta by alpha is alpha beta. Some of you probably wondering, well, how is alpha beta equal to beta alpha? Well, multiplication is commutative. It doesn't matter the order. If I have 2 by 3, that is 6. And if I have 3 by 2, that as well is 6. So it doesn't matter the order, right? So alpha beta is the same thing as beta alpha and so on and so forth. Right? And well, the last one is beta by beta, which is beta squared. I want to find for alpha squared plus beta squared. So I'll make that the subject of the formula. Before I do that, let me just simplify. Right, and guys, you don't have to do all of this in the exam. It's just if you forget this. So I have alpha plus beta squared. Oh god, come on up Ben. Alright, so we'll work with that, right? So I'm gonna group together the alpha squared and the beta squared. So I'm just gonna write alpha squared plus beta squared. And well, I have alpha beta here, and I have another one over here. So I have 2 alpha beta. That look like 3. That look like 2. So that's 2 alpha beta, right? So 2 alpha beta. I want to find for alpha squared plus beta squared. So I would move across the 2 alpha beta. Right? So I want to move across that. So I would end up with alpha plus beta squared. And since I'm moving across 2 alpha beta, it will now become minus 2 alpha beta. Right, and that will be equal to alpha squared plus beta squared. Right? So then alpha squared plus beta squared, that's just equal to alpha plus beta squared minus 2 alpha beta. If some of you guys wondering how I switch it, like how I switch this side and this side, let me explain that too. Imagine you had 1 plus 3 is equal to 4. And I could switch it and it will still make sense. Right, that's still making sense because 4 is equal to 1 plus 3. So you're allowed to flip equations without changing anything. Right? So in the event that you forget what alpha plus beta squared is, alpha squared plus beta squared is, you can do this. Honestly, just remember this, please. Right, so let me continue. Let me continue. I'm putting this in the corner here. So in the previous part, we found what alpha plus beta was, and we found what alpha beta was. So alpha squared plus beta squared is equal to 61 over 4. I just plug in now. So alpha squared plus beta squared was 61 over 4. Alpha plus beta was minus 1 over k. and I had to put that whole thing in brackets because it's alpha plus beta in brackets squared. Right, so I'm going to put minus 1 over k. Right, minus 1 over k squared minus 2 by minus 25 over k. Right. So minus 1 over k squared. What that means minus 1 over k multiplied by minus 1 over k. So minus by minus is a plus, and k by k is k squared. So that will work out to be 1 over k squared. Right? So 1 over k squared. Right? And a minus by minus is a plus. So you're going to end up with 50 over k. Right? Plus 50 over k. Now, hear what, guys? I don't know about you guys, but like, I hate working with fractions. So the easiest way to get rid of all the fractions would be to multiply by the common LCM. Right, the common LCM here would be 4k squared. So I'm going to multiply by 4k squared on both sides. Right, so I'm taking my time with the working so nobody wouldn't get lost. So I have 61 over 4. Right, multiply by 4k squared. And that'll be equal to 1 over k squared by 4k squared plus 50 over k multiplied by 4k squared. The reason I had to multiply by 4k squared is so that, well, this 4 will cancel off, k squared will cancel off, and k would cancel off, because k could cancel off with one of the k's on top, and I'll get rid of the k in the bottom. Right, so let me look at this here. So the 4 and the 4 will cancel off, so that'll leave me with 61k squared. The k squared and the k squared will cancel off, so that'll leave us with 4. Right, and over here, the k, one of the k's in the bottom would cancel off with one of the k's on top, and it would be left with 50 by 4k. Right? So 50 by 4, that's 200k. Right? So that's starting to look like a quadratic. So I'm gonna put it in that form then. So a quadratic is being the form ax squared plus bx plus c is equal to 0. Right? So I'm gonna say 61k squared, and I'm gonna move across everything else so I can get in this form here. So, and if I move across everything, the signs for everything would change as a result. So I'm going to end up with 61k squared minus 200k minus 4 is equal to 0. Right? I put it in the form one time. And again, if you are wondering why is it equal to 0, that's because I take everything on this side and I move it across. So you don't have anything remaining on this side now. Okay. Now that it is in the form of a quadratic, we had to think if we could factor that. Now just by looking at it, we can't factor that. We really cannot factorize that. Right? 61k squared minus 4 and thing, nah. So for this question, you have to use the quadratic equation. So since it is in the form ax squared plus bx plus c, a is equal to 61, b is equal to minus 200, c is equal to minus 4. Right? Let me just get rid of this. So we had to use the quadratic equation for this. CSEC really wanted to mash up the children this year. Right? So if I want to find for k would be equal to negative b plus or minus the square root of b squared minus 4ac all over 2a. That's what k would be equal to. So k would be equal to minus 200, right? That'll be minus 200 squared minus 4 by 61 by minus 4 all over 2 by 61. Right. So minus by a minus is a plus, so you're going to put 200. Right? And you would have to plug this part into your calculator. Right? So everything inside of the SID or the square roots, you plug it into your calculator. Just be careful of the brackets. You need to put in the brackets. So minus 200 squared minus 4 by 61 by minus 4, that is equal to, okay, it doesn't want to focus, that is equal to 40,976. Right, so 40,976 all over 2 by 61. 2 by 61, that's 122. I'm gonna just confirm. Yep. Right, so to figure out my answers, let me consider my positive solution first. So my positive solution, that will be equal to 200 plus the square root of 40,976 all over 122. Right, so let me plug that into the calculator and say what the answer is. So K would have been equal to 3.29856, and typically if they do not specify, you'll round off to 2 decimal places. So my second decimal place is 9, the number after 9 is 5 or more, is 8, so I'll round up. So if I round that up, that'll be 3.30 as my first answer, and my second answer as my negative solution. So I'm just going to change that plus sign there in the middle to a minus sign. Right? I really have to make more space here. Alright. Bam. Like I said, you're just changing a plus sign to a minus sign. And you will get K will be equal to minus 0.019879. And like I say, if they do not specify, you're going to round it off to 2 decimal places. So that's my first decimal place, is my second decimal place. So I'm going to round up, right? So I'd have to increase 1 to 2. So that'll be 0.02, right? And those are my answers. K is approximately 3.30 and K is approximately minus 0.02. Now, I believe this year a lot of teachers would have queried, because at the start they are saying that K has to be in the elements of whole numbers, but clearly K is not whole numbers, right? We'll see that for sure. So that's it for question 1. That's it for question 1B. Right, let me look at question C now. For the quadratic function g of x is equal to minus 5x squared minus 4x plus 2, determine the exact value of the maximum point and the range using the method of completing the square or otherwise. So, first one, let me look at completing the square. Anytime you see completing the square, they are referring to this form here. So, a open bracket x plus h close bracket squared plus k. That's the completing the square form. Right? Now h is equal to b over 2a, and k is equal to 4ac minus b squared over 4a, or c minus b squared over 4a. For simplicity's sakes, I'm going to go with the c minus b squared over 4a, but any one is correct. Right, so what I would have to do is I would have to pull out a, b, and c. So a is equal to minus 5, b is equal to minus 4, and well, c would be equal to 2. So h would be equal to minus 4 all over 2 by minus 5. So I would end up with minus 4 all over minus 10. a negative divided by a negative is a plus, so I would end up with 4 over 10, and if I simplify 4 over 10, I would be left with 2 over 5. Right? Let me find for k now. K would be equal to 2 minus 4 squared all over 4 by minus 5. So k would be equal to minus 4 squared, that is minus 4 by minus 4, so that's 16. 4 by minus 5, that is minus 20. Right, if I plug that whole thing into the calculator, I would get I would get 14 over 5. So, we now have it in the complete any square form. So g of x would be equal to minus 5, open bracket, x plus 2 over 5, 2 over 5 squared plus 14 over 5. Now I'm just going to do a sketch of the graph. So because the coefficient of a is negative, it's sad, right? It's sad, so it'll be a maximum. Right, so I have a maximum here. And the turning point is given by minus hk. Right, my turning point is given by minus hk. So that would be minus 2 over 5, comma 14 over 5. Right, so I would have to shift this graphic to make sense. Right, now we're making sense here. So what's going on is that the x value here is minus 2 over 5, and my y value is 14 over 5. So the highest value this function is going up to is 14 over 5. That's the highest value. So if you want to figure out your range for this function will be g of x is less than or equal to 14 over 5. That's your range. Right, so since the graph is going up to 14 over 5, that's the maximum value. It doesn't go past that. Now, there's an alternative solution to doing this question, and that's using differentiation. Right, because they said using complete any square or otherwise. So, if we want to figure out the maximum point and the range, we could use stationary points and all that. So, look at what I'm talking about. So, differentiation allows us to find the gradient. So, at the turning point here, or the maximum point, my gradient is 0. So, look at what I'm going to do. So, this is the alternative solution to this method over here. So, g prime x, which is the first derivative of g, that would be equal to minus 10x minus 4, right? And if I want to figure out my turning point or maximum point, therefore my gradient would have to be 0. So my first derivative, that literally stands for gradient, so I would just put it equal to 0. So 0 will be equal to minus 10x minus 4, and all I have to do now is just find for x, right? So to find for x, I'll have to move across the minus 4. If I move it across, the sign will change, so that'll become 4. 4 is equal to minus 10x. Let me just switch that around. Minus 10x is equal to 4. So if I want to find for x, I would have to divide both sides by minus 10. Right, so x would be equal to minus 4 over 10, which simplifies to be minus 2 over 5. And if you notice, look at that, it's the exact same thing, right? Since we know the x value of the turning point, we need to figure out the y value as well. So to figure out that, I'm going to take the x value and I'll plug it in into my function to find the y value. So g of minus 2 over 5, that would be equal to minus 5 open brackets minus 2 over 5 squared minus 4 by minus 2 over 5 plus 2. So let me just plug that into my calculator. By the way guys, highly recommend getting a Casio. Casio is king. Avoid sharp by all means, please. Right? Minus 5 open bracket minus 2 over 5 squared minus 4 minus 2 over 5 plus 2. And look at that guys, it's kind of hard to see, but we do end up getting 14 over 5. Let me see if I could just make that bigger. The camera is mirrored, but as you can see, it's 14 over 5. Right. So I know what my turning point is now. I know what my turning point is. My turning point, that would be my turning point is minus 2 over 5 comma 14 over 5, because it's x first and y. Right. And well, if I draw my axes, it will all make sense. So this over here, this is my x value. My x value is minus 2 over 5, and my y value is 14 over 5. Right? And well, my range, since my graph only goes up to 14 over 5, my range would be, well, g of x is less than or equal to 14 over 5. So no matter what the method is, you'll get the same answer. Right? And these are the two methods. You can use completing the square, or you can also use differentiation. Right, so let's look at question 2 now. So in question 2, they want us to write the expression 2 log base 3x plus 2 minus log base 3y as a single term. First of all, let me just put down the ground rules. So I have 3 rules for logarithms. The first rule is the product rule, so that is log base a b plus log base a c. Once you have the same log base, so in this case we have a, and you add in, you can multiply. So that will be log base a b c. Right? The first rule, call that the product rule. Let's look at the quotient rule next. So that will be log base ab minus log base ac, and that would be equal to log base a b over c. And the last rule is the power rule. Imagine you had d log base ab. I could write that as log base a b to the power d. Basically, in the power rule, you could take something, you could take a power, move it to the side, or you could bring it up. So this rule over here works back and forth. Some of you all mightn't be familiar with d, so let me just use c, right? Imagine you had log base a b to the power c. I could take the c and bring it to the front if I wanted, and I could write it as c log base a b, right? And vice versa. If I wanted, I could take the c and bring it up back to the top. I'll get back this exact same thing. So the last rule is interchangeable. That's why you see me put this symbol over here. So for these rules to work, I must have the same exact log base, right? There's one more rule. If you have log base a, that's equal to 1, right? So let me utilize these rules to solve this question here. So first things first, I can take that 2 and bring it up to the top using the power rule, because we want to simplify as much as possible. So I'll end up with log base 3 x to the power 2, and like I said, for me to use any of the log rules, must have the same base. So I could write 2 as 2 by 1, right? 2 by 1, and you see what I'm doing? You see what I'm doing in the next line? Minus log base 3y, right? So in the next line, look at what's gonna happen. If you recall, log base a is equal to 1. So since I can write 2 as 2 by 1, I can write that as 2 by log base 3, because this whole thing over here is 1 according to this rule. And well, 2 by 1 is 2. So we didn't change anything. We didn't change the meaning of anything. Alright? Awesome. So over here, well, I can still simplify more. Let me simplify more before I move on. So since you have it 2 in front, you can bring it up to the top using the power rule. So you're going to end up with log base 3 squared minus log base 3y. So you have log base 3x squared plus log base 9 minus log base 3y. Right, guys? So over here you're seeing a plus. You have plus. You're adding two log terms and you have the same base, so we'll refer to the product rule. So that will work out to be log base 3 9x squared, right, minus log base 3y. Alright, so here now, since we have the same log base and we're minusing, we'll utilize the quotient rule. So I'll end up with log base 3 9x squared all over y. Bam. And that's it there. Right, so look at it, absorb it, soak it in, right? And then move on to B part 1. So they want me to use logarithms to express the relationship v is equal to 7 by 5 to the power t in linear form. Linear form, when you see linear form, they're talking about y is equal to mx plus c. Alright, y is equal to mx plus c. In case you notice, they don't have no powers over here. So in the linear form, there are no powers. Look at this though. You see in a power, you see in t. So what we could do is apply the power rule, which allows us to take our power and move it to the side. But before I could do that, I must have logs. So I have to apply logs on both sides. So let me apply logs on both sides here. So I'm gonna apply logs. By the way, guys, LG just means log base 10. That's a shorthand version for log base 10. So log v is equal to LG 7 by 5 to the power t. Now when you're using logs to transform an expression to linear form, you're basically using the rules in reverse. So in one of the rules you've learned earlier, anytime you have the same log base and you're adding, you can write it as a product. We're going to take that same rule and unravel it. So over here we have log 7 by 5 to the power t. So I can write that as log 7 plus log 5 to the power t. Now some students might take the t and bring it to the side. No, you can't do that. The reason why you cannot do that is because the t is only being, the t is the power for 5 alone, basically. Right? If the whole expression was being raised to the power t, like this, then I could take the t and move it to the side. But you see, that t over there is just to the power 5, nothing else. Right? So now I could write it as log 7. I could take the t, bring it to the side, and I'll end up with log v is equal to log 7 plus t log 5. Alright? Now I want to put it in the form y is equal to mx plus c. So whatever I have over here, it must be an unknown because y is an unknown. The gradient is typically a constant multiplied by x, which is an unknown. And we have c, which is a constant, is a number. Right? So let me put it in our form. So v is an unknown, so I can leave that as is. So I'm gonna write log v. Right, log 7 is a constant, so I had to switch around places, and well, t log 5. T is an unknown, so look at how I'm gonna write it. I'm going to write log 5. I'm gonna write log 5 by t plus log 7. Right, let me compare it now. So y is log v, right, and whatever y is, it has to be an unknown. V is an unknown. M has to be a constant, so that's log 5. Many students get confused when I say log 5 is a constant, but let me explain what I'm talking about. If I put log 5 on my calculator right now, it will give me a number. So let me just zoom up. As you could see, log 5 is in fact a number. So that part there represents a gradient, because the gradient has to be a number. And x has to be an unknown, so that is t. And c is log 7, because log 7 is just a number as well. Right? Log 7 is a number. Check it out. So if I put log 7 in the calculator, it's also a number. So now it is in the form y is equal to mx plus c. Log v is y. My gradient is log 5. X is t. And my y-intercept is log 7. So basically, if I were to plot a graph of log v versus t, and some of you all might be wondering where I get that from, let me explain. Typically, when you're plotting a graph, you're plotting a graph of y versus x, right? Well, we found y to be log v, and we found x to be t. So if I plot a graph of log v versus log t, my y-intercept will be log 7, right? And my gradient will be log 5. So that's what's going on. So watch this again, right? If I plot a graph of log v versus t, this over here, that would be log 7, because log 7 is my y-intercept. That's what the graph is cutting the y-axis, in this case log v. And my gradient is given by log 5. And if I put log 5 in the calculator, log 5 is just 0.6989, so that's a number. Right, guys? So the value for the gradient, m is equal to log 5, and the gradient, that's approximately, well, let me just write it out first. That will be equal to 0.69897700. If I round that off to 2 decimal places, my second decimal place is 9, the number after 9 is 8, so I'd round up. So I would get 0.70. So that's the approximate value for my gradient. Right, and that's question 2AB covered. Let us deal with C now. So in question C, they want us to rationalize the denominator. To rationalize means to get rid of the surds from the denominator. And the way we just do that, we just multiply by the conjugate on the top and bottom. Some of you might probably be wondering, what is the conjugate? Well, the conjugate is just a denominator, but changing the sign in the middle. So 1 plus root 2 all over 3 minus root 2. So if I multiply by the conjugate on both sides, that will be 3 plus root 2, because the conjugate is just a denominator with the sign change in the middle. So when you're expanding this, you expand it using binomial expansion. Right? Well, you expand the top using binomial expansion, and you could expand the bottom using binomial expansion as well. But I'm going to show you all a trick. If you realize, the denominator is in the completing the square form, is in the form a minus b by a plus b and well, that will be equal to a squared minus b squared. Right, so a is equal to 3 and b is equal to root 2. So if I wanted to figure out the denominator, that would just be 3 squared minus square root of 2 squared. That will be equal to 3 squared is 9, 9 minus 2 is equal to 7. So I know that my denominator is 7. Right, so I'm just going to write that one time. My denominator is 7. And the reason I could figure out that so fast is because difference are 2 squares. Right, so one more time, is in the form a minus b by a plus b, where a is equal to 3 and b is equal to root 2. So anytime I have something in this form, it will be equal to a squared minus b squared. So a is 3, so 3 squared is 9, minus b squared, b is root 2 squared is just 2, 9 minus 2 is 7. Right, so my denominator is just 7. I'm going to work out the top now. So 1 by 3 is 3, 1 by root 2 is root 2, root 2 by 3 is 3 root 2, root 2 by root 2 is 2. Right, so 1 by 3 is 3, 1 by root 2 is 1 root 2, or you could just write root 2 if you wanted. Just fix up that. Root 2 by 3 is plus 3 root 2. Root 2 by root 2 is just 2, because root 2 by root 2 is root 2 squared. The square would cancel off with the square root, so just 2. Right, and the next line I could just simplify. So I would group together all the numbers. So I have 3 and I had 2. 3 plus 2 is 5. And I have 1 root 2 here, plus 3 other root 2's. So altogether I have 4 root 2's. So that'll be 5 plus 4 root 2 all over 7. And that's my answer there. My answer is 5 plus 4 root 2 over 7. 4 marks for this is easy marks, boy. Take that win. Right? Let me handle part D now. I noticed in this year they didn't really test here much on series and sequences. Really didn't, compared to other years like 2016 and thing. So over here we have a summation question. Right? We have a summation question. And so this over here is what we will use to generate the nth term. This over here is what we are starting with, and this over here is what we are going up to. And this over here just means to add every term. So to get my first term, I would plug in 0 into this. So that will be 5 to the power 0 minus 2 plus, and we're going up to 4. So that will be 5 to the power 0 minus 2 plus 5 to the power 1 minus 2 plus 5 to the power 2 minus 2 plus 5 to the power 3 minus 2 plus 5 to the power 4 minus 2. Right, you're going to end up with 5 to the power minus 2 plus 5 to the power minus 1 plus 5 to the power 0 plus 5 to the power 1 plus 5 to the power 2. Right, 5 to the power minus 2. That's the same thing as 1 over 5 squared, which is the same thing as 1 over 25. Right? I'm not rush, I'm taking my time. So 1 over 5 squared. This is all the trick I show my students. Imagine you have two parts of this, right? You have a numerator and you have a denominator. The power is negative, it comes like it vex on top, so you go in the bottom. Right? Imagine this. Some family come over, you in your room chilling, and your parents come tell you, hey, look family, and you have to come out, now you get vexed. Right? But when you go back in your room, you'll be happy. So on top here, the power is negative, it vex. So to make it positive, it would go to the denominator. Right? So I will send that 5 to the power minus 2, that whole thing to the denominator, so it will become positive. Right? The same thing for the 5 to the power minus 1. I would send that to the denominator, so it will become positive. Right? So that'll be 1 over 5. Some of you guys might be tempted to say 5 to the power 0 is 0. No. Anything to the power 0 is 1. 5 to the power 1 is 5, 5 to the power 2 is 25, because 5 squared is 5 by 5. Right, so we have 1 over 25 plus 1 over 5 plus this whole thing together, that 5 plus 1 is 6, 6 plus 25, that's 31. So let me plug that whole thing into my calculator. Right, if you plug that whole thing into your calculator, you will get later. You can write the answer as 781 over 25. But I'm gonna write my answer as 31.24. That's the approximate answer. That's actually the exact answer. 31.24. Right? So that's it for part D. Part E now. Determine whether the following sequence is divergent or convergent. Just by looking at this, I can tell you it's convergent. If something is convergent, it converges to a point, meaning it gets smaller and smaller and smaller until it no more adds value to the whole thing, right? If you realize it gets smaller and smaller and smaller, so it will reach a point where the term will be so small that when I add it, it would make a difference. Imagine somebody asks you for 0.00000000001 cents. That is no money at all. So that basically come like 1, right? And furthermore, it even have 0.0000001 cents. So what I'm trying to say is, the more you progress, the smaller your term will be, so the less of a difference it will make. So your values, it will eventually converge to a point. Divergent means that your values getting bigger and bigger and bigger. So the values getting a diversion from each other. The values getting more like further apart. So if we want to show a series is convergent, all we have to do is show that the common ratio is less than 1. Once the common ratio is less than 1, therefore it is a convergent series. So over here we have a GP, because only in GPs is have convergent series. And so if I want to figure out my common ratio, that will be equal to my second term over my first term, or I could say my third term over my second term, and that brings me to the general formula. The general formula for common ratio is Tn plus 1 over Tn. So it's the next term divided by the previous term. So let me just take the second term. Second term is minus 2 over 3. Minus 2 over 3 divided by 1, that will be minus 2 over 3. Right? The third term divided by the second term, that's 4 over 9 all over minus 2 over 3. So guys, I highly advise getting a Casio. Casio will save your life, because with a Casio you can plug it in exactly how you're seeing it. Alright, so check this out. I know my camera inverted, but I just make it bigger. It's really hard to see, but with Casio, essentially you could plug in the fractions exactly how you see it. With a sharp, can't do that. Not at all. Right, so 4 over 9 divided by minus 2/3, that will give you back minus 2/3. Right, so since r is less than 1, the series is convergent. Bam, and that's it there. That's it. Right, and that is it for question 2. In question 3, they want us to determine the points of intersection of the circle and the line y is equal to x minus 6. So, a circle. This is what a circle does look like. Everybody knows what a circle does look like. And everybody knows what a line does look like. So, if we have a circle and a line, the least points of intersection is 1, and that's at a tangent. Or, well, typically speaking, normally you have 2 points at intersection, because a line could cut a circle at 2 points, right? I'm talking about here and over here. So that's what I'm mentally preparing myself for when I do this question. So in this question, we have to solve a pair of simultaneous equations. Now we can't use elimination, and well, we definitely don't want to use matrices. We can't, because we have a linear and a quadratic. The only one we could use is substitution. And the objective there is to get rid of one of the unknowns, so that we only had to work with one. So in the question, they are telling me that y is equal to x minus 6. So anyway I see y in this equation, I'll just replace it for x minus 6, so that I will end up with something that only has x in it. So I would have one unknown to find for. Right? So let me just write back the equations real quick. So x squared plus y squared minus 4x plus 6y plus 8 is equal to 0. That's equation 1. The other one is y is equal to x minus 6, and that's equation 2. So like I said, we can't use elimination method and we can't use matrices method. So we had to use substitution, and the objective there is to end up with one unknown. So we're going to make a substitution. Well, we're going to express one unknown in terms of the others. Well, in terms of the other, and we'll plug it in and go from there. So anyway I see y in equation 1, I'm going to replace it for x minus 6. So x squared plus x minus 6 squared minus 4x plus 6 by x minus 6 plus 8 is equal to 0. So anywhere I saw y, I replace that whole thing for x minus 6. Alright, next line. So a lot of students might make this mistake here, right? A lot of you guys might say, well, x minus 6 squared, bam, that x squared minus 36 for sure, for sure. No, don't do that. What you're doing, right? To expand that, you have to use binomial expansion. So x minus 6 squared, what that means is x minus 6 by x minus 6. Right? This part over here, we could expand that. So to expand it, I'm going to say 6 by x, and I'm going to say 6 by minus 6. Alright guys, so 6 by x is 6x. 6 by minus 6 is minus 36. Plus 8 is equal to 0. Nice. Next line. We have to expand further. So I'm going to do binomial expansion. So x by x, x by minus 6, minus 6 by x, minus 6 by minus 6. Right. So x by x is x squared, x by minus 6 is minus 6x, minus 6 by x is minus 6x again, minus 6 by minus 6, negative by negative is a plus. That will give me plus 36, minus 4x, plus 6x, minus 36, plus 8 is equal to 0. So in the next line, I will group together all my like terms. So x squared and x squared, those are examples of like terms because it is the exact same thing. So I have two x squareds there, right? Because I see in 2, I have two x squareds. So I'm going to write 2x squared, right? Then I'm going to look at the x terms. I have minus 6x there, and I have minus 4x plus 6x there. So minus 6x is minus 12x, minus 4x plus 6x, that is 2x, right? And minus 12x plus 2x, that would work out to be minus 10x. Right, and now we're going to look at the numbers. So over here I have 36, and I have minus 36, so that will cancel off. So the only number I really remain with is plus 8, and that'll be equal to 0. Now, all the terms over here, are multiples of 2. 2 by 1 is 2, 2 by 5 is 10, 2 by 4 is 8, which means I could divide throughout by 2 to simplify my quadratic. Right? So I would divide both sides by 2. So 2 into 2 is 1, so we get 1x squared. 2 into minus 10 is minus 5x. 2 into 8 is plus 4. And that will be equal to 0 because 2 into 0 is just 0. Alright, so now we had to factorize. And guys, remember at the start, I mentioned the highest degree of x tells you how much answers you're going to have. Well, over here we have a quadratic, and we're going to have 2 answers. And at the start, I said, if you have a circle and you have a line, typically, a line will cut a circle at 2 points. And that's what we're expecting, right? We're expecting 2 solutions. So, first things first, I'm going to open up my big pair of brackets, right? To get x squared, I would say x by x. And to get 4, now typically, I would say 1 by 4, right? But if I add 1 and 4, no way I could get minus 5. So I had to think to myself, where's another way I can multiply to get positive 4? But the only other way is minus 1 by minus 4, right? And negative by a negative is a plus. And if I add together minus 1 and minus 4, I will get minus 5. So that's it there. And if you want to check over, you can expand quick. X by x is x squared, x by minus 4 is minus 4x, and you have minus 1x, minus 4x minus 1x is minus 5x, and minus 1 by minus 4 is 4. So that does check out. If you do your quick check back and it's not working out, try back again. Something wrong. Right, so now I have x minus 1 is equal to 0, and I have x minus 4 is equal to 0. So, x would be equal to 1, because if I move across the minus 1, the sign would change. Same thing over here. If I have minus 4 and I move it across, the sign would change. Right? So x would be equal to 4. So I have 2 values for x. But I wanted to find the points of intersection. Now a point consists of an x and a y value. So we ain't done yet. So now that I know what x is, I could find for y using x. If you recall, the second equation was in terms of was y in terms of x. So now anywhere I see x, I could just replace it here and I'll find the value for y. So let me start off with x is equal to 1. When x is equal to 1, y would be equal to 1 minus 6. 1 minus 6 is minus 5, right? And let's check out the other one now. When x is equal to 4, y would be equal to 4 minus 6. So y would be equal to minus 2, right? So what I just now did, since I have x, I just have to plug it in over here to find for y, because y is literally equal to x minus 6. So whatever x is, you take away 6 from it, and that'll be what y is. So my 2 points of intersection are 1, minus 5, because it's x first then y, right? And then it is 4, minus 2. So those are my 2 points of intersection. And as I said before, we expected that, because normally a line would cut a circle at 2 points. So bam. Easy 5 marks here, if you know what you're doing. Alright, let me move on to part B now. Now this question, in my opinion, is a piece of cake. So B part 1. Given that the coordinates of the points A and B are 7 minus 3 and 2, 1 respectively, state the position vectors corresponding to the points A and B in the form xi plus yj. So position vectors means that we started from the origin. So we started from the origin 0, 0. So let me explain what went on. Imagine you had a pair of axes. Over here is your y, over here is your x. 7 minus 3 means that you'd have started 0, 0. You would have moved 7 spaces to the right, and then you would have moved 3 spaces down. And that would have been point A. So if you want to go from O to A, right? If you want to go from O to A, you had to move 7 to the right and then 3 down. So my X movement is 7 and my Y movement is minus 3. And that's the gist of it, you know. So all I had to do now was just put it in this form because I know what X and Y is. So vector O to A, that would be equal to 7i minus 3j, right? And O to B, that would be equal to 2i plus g. You could say 1j, you could say j, all means the same thing. Alright? And now they want me to figure out A to B. Now if I'm going from A to B, this is what's going on. Right? I want to go from A to B. Let me just say you traveling from Pinal to Port of Spain, right? You don't just go straight unless you're rich and you can hire a private car, right? Typically what you had to do is you had to go from Pinal to San Fernando, then San Fernando to Port of Spain. So watch this. Let me just say going from A to B costing too much money. What you gonna do is you go A to O and then O to B. Since you're going opposite direction of O to A, you'd have to change the sign for vector O to A. Because O to A is in the opposite direction. Anytime you go in the opposite direction, you change your signs. So if I want to go from A to B, that would be equal to A to O. And when I reach O, from O, I'll go to B. Right? Like I said, since we're going in the opposite direction, you change the signs. So A to O, that would be minus 7i plus 3j. And O to B, that's plus 2i plus j. I'm going to group together the like terms. So minus 7i and 2i, that would work out to be minus 5i. Right? And 3j, I had 3 j's and I have another j. Altogether I have 4j. And that's it there. That's A to B. In part 3, they want us to figure out the scalar product or the dot product. Easy thing. They really give away the vector questions this year, I feel. Right, so if I want to figure out the dot product, all I have to do, I have to multiply the corresponding movements and then add them. So first of all, I'm gonna multiply the corresponding x movements. So that will be 7 and 2. And then I'm gonna multiply, so I'm gonna multiply 7 by 2, and then I'm gonna add that to the product of minus 3 and g, which is just 1. So OA dot OB, that's gonna be equal to 7 by 2, right? So the product of the x movements plus the product of the y movements. So minus 3 by 1. Because j is just 1j. And you're going to end up with 14 minus 3. 14 minus 3, that's just 11. This question was cake, honestly, on God. All I had to cook in this question, for sure. Right? Let me deal with this question now. A little trickier, how we going to manage. Using the letters P, Q, and R, write an expression for each of the following trigonometric ratios. Alright, first things first, let we identify what angle we're using. Well, we're going to use this angle over here, theta. So let me just label accordingly. This is my hypotenuse, this is my adjacent, well, and this is my opposite. Let me explain why I labeled it like that. This is my hypotenuse because the hypotenuse is the longest side in the triangle. It's always the slant one. This is my adjacent because it's adjacent to my angle, like right next to my angle. And this is the opposite because it's opposite to my angle. Alright? So sine theta, according to SOHCAHTOA, sine is equal to opposite over hypotenuse. But in this question, we're not dealing with O and H. We're dealing with P, Q, and R. So O over H, that would be the same thing as P all over Q, right? And cos theta now. Cos theta, that is equal to A over H K, right? But we're not working in terms of A and H. Instead, we are working in terms of R and Q. So that is what sine theta and cos theta is equal to. Yeah. Alright. Part 2 is the one with pressure. So in part 2, they're saying use your answers in C part 1 to determine the values of sine squared theta and cos squared theta. Well, we know what this is equal to. Like, yeah, this is like the most obvious identity in trigs, right? And is equal to 1. So we're trying to prove that sine squared theta plus cos squared theta is equal to 1. It will be alright. So they are telling us that sine squared theta is the same thing as sine theta all squared, right? And it's the same story for cos squared theta. Cos squared theta is just whatever cos theta is squared. Alright, so I have sine squared theta plus cos squared theta, right? Now sine squared theta does the same thing as sine theta all squared plus cos theta all squared, right? And we know from above that sine theta is P over Q, right? Sine theta is P over Q, right? And well, cos theta is R over Q. Lovely. I just want to make something very clear. P over Q squared, that means P over Q multiplied by P over Q. Right? So that will be equal to P squared over Q squared. Right? Just clearing up any confusion that might be there. So you'd end up with P squared all over Q squared. Right? And the same story over here. You're going to end up with R squared over Q squared. Guys, if you notice, we have the same denominator, so you can literally just add there. You end up with P squared plus R squared over Q squared. Now, boy oh boy, that's not looking like one, isn't it? Well, that's where our partner Pythagoras coming in. Big up Pythagoras, right? Pythagoras is a real one. So according to Pythagoras theorem, well, Pythagoras theorem states that the hypotenuse squared is equal to the sum of the other two sides squared. Alright, so let me just put that down here. My hypotenuse in this question is Q, so Q squared will be equal to the sum of the other two sides squared. So Q squared will be equal to P squared plus R squared. Alright, guys? And we can only use Pythagoras theorem because we're dealing with a right angle triangle. Right. So, since Q squared is equal to P squared plus R squared, I can make a nifty little substitution. Look at that. You guys seeing it? So P squared plus R squared, I could replace our whole thing for Q squared. Bam. Right? And what is Q squared over Q squared, boy? A real wonder. Is 1. Right? Anything over itself is 1. Because Q squared can go into itself 1 time. So my answer is 1. And that's how you handle a question like this. A lot of students would have probably freeze up over here. Yeah. But you can't forget the G, Pythagoras theorem. Right. So that's it for this trig question. I move on to the other question. So we have a proving the identity question. Of course. And they can't leave out this. Right? So I tell my students these basic rules. Whenever you're dealing with a trig proof, right? Anytime you see tan, like over here, how you see in tan A, immediately convert that to sine A over cos A. Don't play around. Replace that 1 time. Another thing. If you're converting division to multiplication, you have to invert. Let me give you an example. Imagine you had 1 divided by a half. I can write that as 1 divided by a half, and if I change that to multiplication, I would flip, and that would now become 2 over 1. So 1 over a half is essentially 2. You'll see how I will utilize that just now. Right? The other thing is, if you have different denominators, find your LCM. Different denominators, find your LCM, guys. So let me take that advice and throw it into this question. So tan A. I saw custom saying tan theta, boy. Right? If I want trouble all different and thing, I could ask them what sine t over cos t is. And I'll go drop in the chat what are equal to sine t over cos t. Right? Anywho, let me begin. So tan A is sine A over cos A. Right? And I'm replacing that in the denominator as well. Sine A over cos A. Right? Now guys, you see this part over here? I could write this part. Let me show you how I could write this part. I could write that part as 1 divided by sine A over cos A, and that's because that is what it means. Right? Anytime you have something in the denominator, that means you're dividing. Right? So 1 divided by sine A cos A. And now if I wanted, I could change that to multiplication. Anytime you're changing something to multiplication, you have to flip it. So that will become 1 by cos A over sine A. Right? Which just works out to be cos A over sine A. Right? Bam. So I end up with sine A over cos A plus cos A over sine A. Right? I have different denominators. You know what I mean? That means to find your LCM. Right, guys? I have to find LCM there. So the LCM between cos and sine, that is sine A cos A. Or cos A sine A, anyhow you want to see it. Right? This is a little trick, right? If you're having trouble finding the LCM, more than likely you can multiply your 2 denominators. Because the common LCM, what does that mean? Common lowest multiple. Right? Lowest common multiple. So we're looking for something that cos A could go into and sine A could go into. The smallest one is sine A cos A, because sine A cos A is a product of these two. So cos could go into it and sine could go into it. Right? So cos A into sine A cos A. I'm going to show you how that will work out. Sine A cos A all over cos A. Right? Cos A will go into it and it will leave sine A. So then I'm taking a sine A and I'm multiplying it by this sine A on top here. Right? And I will end up with sine squared A. Sine A will go into this and it will cancel off with the sine A. And then the cos A will multiply by the cos A on top. Cos A by cos A is cos squared A. And what you know, in the previous question we went and proved that sine squared theta plus cos squared theta was 1. So we're going to use it here again. So you're going to put 1 over sine A cos A. And I believe that's what they wanted it to prove. Yep, that's what they wanted it to prove. And that's how you handle a question like this. So take it in there, right, before we move on. Alright guys, so just some general tips. Anytime you see tan, immediate conversion, sine over cos. Anytime you see divide, change it to multiplication. If you have different denominators, find your LCM. Simple procedures. Right, and of course we can't forget to put SpongeBob here, in your little square. Right, I wish I had a picture of SpongeBob. Let me just put SpongeBob here. Oh Lord. I don't know what kind of SpongeBob this is, but oh well. This is SpongeBob here. Right, but anytime you finish a proof question, you can write QED or you could draw a square. Right. So, on to the calculus part of the test. This first question probably scare a lot of people that wrote the test, because this is like in fine print in the syllabus, you know, and limits isn't really taught at the art maths level. You typically learn limits in unit 1 pure maths, right? So this question was a kind of gray area, you know, but let's just say it come the other year, at least you gonna know what to do now. So they want me to use the definition of the derivative as a limit to find f prime x for the function f of x is equal to x squared minus 3. So they want me to find the derivative of f of x, right, using the definition of a derivative. What is the definition of a derivative? Well, the definition of a derivative is simply gradient. When you differentiate, you're finding dy over dx, the change in y over the change in x. So the first derivative just quite literally means gradient. It literally just means gradient, right? So if I want to find the first derivative or gradient of the curve x squared minus 3, is what we had to do, right? Check it out. Imagine I were to just sketch a graph. We have x squared minus 3. Since the coefficient of x squared is positive, have a happy face, so it's a minimum. We're dealing with a minimum here, right? Now that's just an estimate location on the graph. It's nothing too accurate, right? But let me just say that I wanted to figure out the gradient at that exact point. That's kind of problematic because it's not a line we're dealing with. The gradient will be different at every single point. Let me explain. For those who don't understand what gradient is just how steep something is. Imagine you're driving up a road. This over here will be a steep road. This over here will be a flat road. This over here will be a steep road. Gradient is just how steep something is, like the altitude now. So if something is more steep, less steep, they have different gradients. And that's what we have in a curve, right? In a line, the steepness is the same no matter what point we at, right? Because it's a straight line. But on a curve, over here it's steep. Over here it's not so steep. It's flat. Over here it's getting back steep. So that's the problem with our curve. The gradient is changing every single place. Now we could estimate the gradient. In maths, you would have probably learned that you could draw a tangent to the curve and then take 2 points and find the gradient. But that's not what they want me to do over here. Over here, they want me to take another point on the line. So let me just put a point there. And I'm going to draw a line through that. Now suppose we want to find the gradient at this point. Well, the gradient at this point wouldn't be the same as this gradient over here, but it could be an estimate. Imagine you have a line over here. The gradient at this line in blue, like I say, it wouldn't be the exact gradient of this green point over here, but it will be a close estimate. Now what happens when I take the point and I move it closer? Let me see what happens. I want you all to notice what's happening. The gradient at that line, it getting closer and closer to the actual gradient at this point. And if I take the point and I put it over here now, look at that. So what I'm trying to say is that the gradient of the line, the more you're closing the distance, the gradient at the line approaches the actual gradient at this point over here. And that's the concept of limits basically. Basically with limits, you're looking to see what happens as you approach a value, right? In this case, we're trying to approach a distance of 0. Right? We're trying to approach a distance of 0. So time to actually get working. So how are we gonna do this, right? Imagine this over here is point X. Let me just change back my pen, right? Imagine this over here is some distance X. And this over here is X plus H. The reason why it is X plus H is because it is some distance more than this point over here. And as you would have seen just now, the aim is to make sure the distance is 0, right? And let we not forget to label the curve. This curve over here is equal to x squared minus 3. X squared minus 3. So if this point over here, well, it kinda a little off. Let me just fix that. If this point over here is x, then the y value for that would be f of x, because my graph is f of x, right? If this is x, I would plug it in into f of x to find my point. So this over here is f of x. And well, if that is the case, this over here, if I want to find the y value for this point, whatever it may be, but seeing this is x plus h, all I would have to do, I would have to plug it in into my function, right? So I would have to put f of x plus h into my function. So I have 2 points here. So this point over here, this is x, comma, f of x, right? And my other point is x plus h, because it's some distance away from x, comma, f of x plus h. And like I said, guys, if I want to get a very close value for the gradient at that point, I'll have to make sure that this distance h approaches 0 as much as possible, right? So that the line would basically fit in for the same steepness at this point over here, right? So we're trying to see what happens as the distance from the 2 points approaches 0. So let me just put on our formula for gradient. So gradient is equal to y2 minus y1 over x2 minus x1, right? So let me just label this x1 y1, and let me label this x2 y2. So I will end up with, and keep in mind this gradient over here, that's the estimate gradient, right? That's the gradient you'll be finding for this line over here, not the gradient at this point just yet. So y2 minus y1, that would be f of x plus h minus f of x all over x plus h minus x. Alright, guys? So that over there is a general formula to figure out the approximate gradient at this point here. Now if I want to figure out the actual gradient, what I would have to do is I would have to find a limit as it approaches 0. Like as this approaching 0, that's what I would have to do. So f prime x would be equal to the limit as h approaches 0. So as the distance between the 2 points approaches 0, I get an even more accurate reading for my gradient at this point, like I was saying. So I have f of x plus h minus f of x all over x plus h minus x. My function is x squared minus 3, so let me begin to plug in, right? There's plenty writing for this question. I don't know what CXE was thinking, right? So I have to plug x plus h into this function. Anywhere I see x, I replace it for x plus h, right? So x plus h squared minus 3, This one is just f of x, so I'm going to write back f of x, but be careful, don't forget your brackets. Minus x squared minus 3. And in the bottom is just x plus h minus x. Right? Let me expand the top now. So on top, you're going to have x plus h by x plus h, because x plus h squared, that means x plus h by x plus h, right? Minus 3 minus x squared. After expand, so the minus sign on the outside, it will apply to all the terms on the inside, right? So minus by x squared is minus x squared, minus by minus 3 is plus 3. Right, so x by x, I had to do binomial expansion here. Let me just put in that. So x by x is x squared, right? X by h is xh. H by x is xh again. H by h is h squared, right? And well, this minus 3 and this plus 3 go cancel off. So I just remain with minus x squared. Right, and in the bottom, the x and the minus x will cancel off. So it will leave me with h in the denominator. Right? So what would happen next is that the x squared and the minus x squared, those two terms would cancel off. I have two xh's, so I will write 2xh plus h squared all over h. So this is what I now have. And if you realize, I have h over here and I have h over here, so I could factor out the h now. We nearly finished, I promise, guys. I promise, we nearly finished. Right? So I'm going to factor out the h. So if I factor out the h from 2xh, I'll be left with 2x, because 2x by h is 2xh. So if I pull out the h, I'll just have 2x. And h squared, if I pull out the h from h squared, which means h by h, I'll just have h, right, all over h. Finally, the h in the bottom would cancel off with the h on top. Now you all would probably be wondering, if h approaching 0, why I didn't say that over here? The reason why I can't do that is because I cannot divide by 0. So that's why I was trying as much as possible to get rid of that h in the bottom. I had to get rid of it. So now we end up with a limit as h approaches 0 for 2x plus h. And this is a good point now, because if h approaching 0, then I will just be left with 2x. Finally, right? So if the distance between x and x plus h approaches 0, my gradient will be given by 2x. Phew. That was a lot there. That was a lot for real. Right? Okay. So my answer is 2x. And well, if you differentiate normal, you wouldn't get any marks. You probably get like 1 mark. Well, if you differentiate normal, you'll get the 2x as well. But you wouldn't get any marks really, because you didn't prove the concept. Right? So 2x is what f prime x is equal to. Let me figure out the value of f double prime 5. So f prime x, which is the first derivative, is equal to 2x. And if I differentiate 2x, I will be left with 2. And so f double prime 5, that will just be equal to 2, because I don't have no x to plug that 5 into. So my answer is just 2. Real idiotic question in my opinion. Right? But in my opinion, this was the hardest question in paper. Everything else was kick. Well, minus This one was had a little problem with this question. Right, so the problem was that it's supposed to be whole numbers. Right, so let me move on now. They're saying that given y is equal to sine x over cos x, show that dy over dx is equal to 1 over cos squared x. I have a feeling that you're gonna have to use trigonometric identities here. I have a feeling. But let me see. So y is equal to sine x over cos x. Right? Since we have a quotient, you gotta use the quotient rule. So sine x would be u and cos x would be v. So if you're using the quotient rule, you gotta remember it first of all. And the quotient rule goes something like this. If you're differentiating u over v, that is equal to v du dx minus u dv dx. All over v squared. All over v squared. Right? So I know what u is. Let me just write it separately. So u is equal to sine x and v is equal to cos x. Right? So if I want to find du dx, if I differentiate sine x, I will get cos x. And if I differentiate cos x, I'll get minus sine x. So now that I know what u, v, du dx, dv dx is, I can plug it in into the formula and get my answer. That looking like a v. Let me fix that there. Right. Now we know that. So dy over dx, that would be equal to v. V is cos x by du dx. Du dx is also cos x minus u. U is sine x by dv dx. dv dx is minus sine x all over v squared. Now v is cos x, so cos squared x is just cos. It's just cos squared x. It don't trick about that, right? And that's what I use for the for this question over here. Matter of fact. So v squared, v is cos x. I will change it to the other line, right? But essentially that's what's going on. V squared is cos x squared. So we're gonna end up with cos x by cos x is cos squared x, right? A minus by minus is a plus, so I'm gonna end up with plus sine squared x all over cos squared x, right? And we know from the previous question that cos squared x plus sine squared x, or sine squared x plus cos squared x, is equal to 1. So that's how I get my answer, 1 over cos squared x, right? I had to draw my little SpongeBob here, right? Because I proved it. Because it wanted me to show that. And that's how you handle a question like this. Anytime you have a quotient, or you divide into things, use the quotient rule. V du dx minus u dv dx over v squared. That's the way to go. Right? Let me look at the other question now. The equation of a curve is given by y is equal to 5x squared minus 7 close bracket to the power 4. Already smelling from a mile away, chain rule. Immediately. Anytime you're dealing with a question and have a ugly power, meaning that is more than 2, you have to use the chain rule. Because let me think about it. If you had to differentiate that normally, you'd have had to take 5x squared minus 4 and multiply it by itself 4 times, and then you had to expand and simplify and then differentiate. That's too much stress. So they want me to figure out the equation of the gradient of the curve. Gradient is just dy dx, so we had to differentiate. Anytime you see gradient and thing, they just want you to differentiate normally. Right, so we had to differentiate this over here. Like I said, that 5x squared minus 7 to the power 4, die bacchanal. So we had to use the chain rule. So I'm going to write it back. Y is equal to 5x squared minus 7 to the power 4. Now we're going to ask a question. Drop in the chat. what do you think causing the trouble? Are you think 5x squared minus 7 causing the trouble? Or to the power 4? Plenty of you go say to the power 4. But I want to show you something. What if it was y was equal to x to the power 4? Then that would be really easy to differentiate. That would just be dy dx is equal to 4x to the power 3. Because when you differentiate, you take the power, you put it in front, and then you minus 1 from the power. So if you ask me, the 5x squared minus 7 is what caused any trouble. Right? Because if it was x alone, I'd be able to differentiate that real easy. So I'm going to make a substitution. Right? I'm going to say, let u be equal to 5x squared minus 7. And in doing that, I will now be able to write it as y is equal to u to the power 4. Because then I'll say this whole thing is u. And I could differentiate that real easy. Right? So I had to differentiate these two things. I had to differentiate u and y. Over here, I'm going to differentiate the function u with respect to the unknown x. So I'll write that as du over dx. I'll look like a y. I'll fix that. Yeah. So du over dx, that will be equal to, I take my power, multiply by the number in front, and then minus 1 from the power. So that 5 by 2 is 10. If I minus 1 from 2, I'll just get 1. So du dx is 10x. When you differentiate a constant, we just get rid of it. So if it don't have x in it, it vanishes. That's it. Over here, we are going to differentiate the function y with respect to the variable u. So I will write that as dy over du. When you differentiate it again, you're taking the power, you're putting it in front, and then you're minusing 1 from the power. So 4u to the power 3. So now I have du dx and I have dy du. But at the start I wanted to find for dy dx, because at the start I had y and I had x. This is where chain rule comes in. Anytime you had a link two different rates of change, you use chain rule. Right? So using chain rule, I wanted to get I wanted to find for dy dx. I wanted to find for dy dx, and so dy dx, that would be equal to dy over du multiplied by du over dx, and it works out because the du and the du will cancel off, and I'll get back dy over dx. Now it just so happens that I have dy over du and I have du over dx, so now we're just going to plug in. So dy over du, that's 4u to the power 3, and du over dx, that's 10x. Right, guys? So I'm gonna multiply what I can multiply. So 4 by 10 is 40. Right? 40x u to the power 3. Now in my final answer, I don't want any u's because it's y with respect to x. So I'm going to remember the substitution I did make at the start. At the start, I said u was equal to 5x squared minus 7. So now I'm going to recall that. So I'm going to write 40x, open bracket, 5x squared minus 7, close bracket, all to the power 3. And that's how you handle a question like this. Anytime you see now weird power, like once the power is more than 2, or is a fractional power like a half or something, you have to use chain rule. Right? And basically, in the chain rule, you're going to let whatever inside the bracket be equal to u, or whatever letter you choose, to simplify the problem. You're going to end up with two different rates of change. So in this case, we ended up with du over dx and dy over du. To combine that and get the dy over dx, I had to use the chain rule. So in the chain rule, you're just multiplying two different rates of change to get the one you want. And we was after dy over dx, and we end up with that. Right? So on to question 5 now. Question 4 was mainly differentiation, so I suspect that question 5 will just mainly be integration. So the first question, the region enclosed between the curve y is equal to x squared plus 1, the x-axis, the y-axis, and the line x is equal to 2 is rotated about the x-axis through an angle of 360 degrees. Calculate the volume of the solid of revolution that is formed. So what we have here is we have a curve y is equal to x squared plus 1, and it's enclosed by the x-axis and the y-axis and the line x is equal to 2. So let me just draw a sketch. So little sketch. So x squared plus 1. Since the coefficient of x squared is positive, it's happy, so that's our minimum we're looking at. So my curve could probably look a little something like that. Alright? I'm gonna say it looking like this probably. I'm just gonna say that. Right? So we're mainly looking at this portion over here. Right? So they're saying that they want me to figure out the volume of the solid of revolution that is formed when I rotate this curve 360. So they're saying that it is enclosed by the x-axis. So let me just put my labels. This is my y-axis. This is my x-axis. So it is enclosed by the x-axis, the y-axis over here. Now the y-axis, another way to write the y-axis is x is equal to 0. Right? And they're saying that it is bounded by x is equal to 2 as well. So let me just say that this over here was x is equal to 2. Let me just change this color. Yeah, let me just say that this was x is equal to 2. The OCD kicking in, boy. Alright. Okay. Let's get back that orange color. Alright, nice. So imagine I have this portion of the graph. So I have this portion of the graph here. I get a green. Wait, but I don't know green. I get a green here. Right. So imagine I have this shape and I take it and I rotate it 360 degrees. So I'm taking the shape and I'm rotating it 360 degrees. Let me show you what will be formed. Right. So this is what will be formed if I take it and I rotate it 360 degrees. If I take something and I rotate it 360 degrees, it could be a 2D shape, but I will still create volume. So I'm taking this shape, I'm taking this flat shape, this area, and I'm rotating it 360 degrees. Right? Like I say, in doing so, you will create volume, as you can see here. Right? Un momento. I just have to fix this thing here. Right. So if you were to take that flat shape and rotate it 360 degrees about the x-axis, some volume would be created. And anytime you want to figure out the formula for volume, anytime you want to figure out volume, you use this formula here. V is equal to pi integral between the upper limit b, lower limit a, y squared dx. So if you want to figure out volume as a result of rotating a shape 360 degrees, that's what you have to use. So my lower limit is x is equal to 0, and my upper limit is x is equal to 2. Right? And y is equal to x squared plus 1. So before I start to integrate, let me just square it one time. So y squared, that will be equal to x squared plus 1 squared. Some students might say y squared is equal to x to the power 4 plus 1 and thing, but no. What y squared means is that you have y multiplying by itself again. So if x squared plus 1 is y squared is just x squared plus 1 by x squared plus 1, as you will see now. right? And I have to do binomial expansion. So x squared by x squared, 1 by x squared, 1 by x squared again, and 1 by 1. Right? So y squared, that would be equal to x to the power 4, because I have x squared is x by x, and I'm multiplying it by x again. So I'm going to end up with x to the power 4, because I'm multiplying x by itself 4 times. 1 by x squared is just x squared, 1 by x squared is just x squared, and 1 by 1 is just 1. Right? So let me just group together the like terms. So I have 2x squared, so I could write x to the power 4 plus 2x squared plus 1. So now I'm ready to find volume. So volume, right? Right, if I want to find volume, volume would be equal to, let me just put my limit something one time. So my upper limit is 2, lower limit is 0. Y squared is x to the power 4 plus 2x squared plus 1 dx. So V would be equal to pi. I open it up my square brackets because I'm going to integrate now. When I'm integrating, I'm adding 1 to the power, and then I'm dividing by that new number. If I add 1 to the power 4, I'll get 5, and then I will divide by 5. Over here, if I add 1 to 2, I'll get 3, so I will divide by 3. And if I integrate 1, I will get x. Upper limit is 2, lower limit is 0. Fun fact, guys, a Casio could do this whole question for you. Literally. Casio calculators are goated. Right? Right now I can't get the Casio calculator on the screen, but maybe in next recordings I would be able to. Right? So, let's proceed. So V would be equal to pi. I would have to open a big square bracket, open a smaller bracket, and what I'm going to do now is I'm going to plug in 2 into this, minus it from when I plug 0 into it. So I'm going to write 2 to the power 5 over 5 plus 2 by 2 to the power 3 all over 3 plus 2. Right, and then I'm going to minus it, but instead of putting in 2, I'll put in 0. And just a little life hack. You see how everything over here has x in it? The whole other bracket will just be 0. That's a little fun fact to save time. Because everything here, all the terms have x in it. So that'll just work out to be 0. Just imagine how much time that will save you in the exam, if you know that. Right, so 2 to the power 5, that's 32. So you're going to put 32 over 5. 2 to the power 3 is 8. 8 by 2 is 16. You're going to end up with 16 over 3 plus 2. And I'm going to plug that into the calculator now. Right. Right, so the exact digit for volume, that will be 206.15 by pi. And if you wanted to set an approximate value, that would be the approximate volume would be 43.14 units cube. Right, since it's volume, the units would be cubed. The full answer I had got was 43.14453,911, and anytime I don't specify, you round off for 2 decimal places. So my second decimal place was 4, and the number after 4 is less than 5. So I just get rid of everything else past that 4. That's how I end up with 43.14. And that's how you handle a question like this. Right, so let's move on to the other one. A little bit of kinematics. So part B. As a particle moves along a straight line, its displacement is measured from a fixed point O on the line. At time t seconds, the acceleration A is given by A is equal to 24t minus 14. Find the expression for the velocity v of the particle given that t is equal to 1 and v is equal to 3 meters per second. Okay. So, they are giving us a formula for acceleration. So they are telling us directly that acceleration is equal to 24t minus 14. Acceleration is the rate of change of velocity with respect to time. So acceleration is dv over dt, right? And in part 1 they want me to find the velocity. So if acceleration is dv over dt, then to find velocity I would have to integrate acceleration. So that is exactly what I'm going to do. So I'm integrating dv over dt with respect to time, and that would be equal to the integral of 24t minus 14, and I'm integrating with respect to time, so I have to put the dt. Right, so if I integrate this, dt and the dt would cancel off, and if I integrate dv, I'll get velocity. Bam, so that works out nicely. Right, again, when I'm integrating, whenever you are integrating, you have to add 1 to the power and divide. So 24t, that's understood to be to the power 1, so I will end up with 24t to the power 2 all over 2, and I would slap on a t in the minus 40. And since it is an indefinite integral, I have to add a plus c. Now I like to think of c as a condition, right? Now if I want to find the exact equation for velocity that would fit the conditions, I have to use what they give me. So they tell me when time is 1, the velocity is 3. I could use that to actually find for c. And like I say, I like to think of it as a condition for this specific equation. So I'm going to put that in here. When t is equal to 1, my velocity is 3 meters per second. And that's what we know. We know that. And I'm going to use that to find for c, to complete the equation. But before I do that, this will cancel off. 2 into 24 is 12. I would end up with 12t squared minus 14t plus c. Anywhere I see t, I replace it for 1. Anywhere I see v, I replace it for 3. And I make c the subject of the formula. Right, so 3 is equal to 12 by 1 squared minus 14 by 1 plus c. Right, 3 would be, well, 3 is equal to 12 by 1 squared. 1 squared is 1, 12 by 1 is 12. Minus 14 by 1 is just minus 14 plus c. I'll leave more space. Let me just come here. Right, 12 minus 14, that works out to be minus 2 plus c, and I'm trying to find for c. So everything that is not c, I'll move it across. So I will move across the minus 2. When I do that, I will end up with 3 plus 2 is equal to c. So c would be equal to 5 then. So now that I know what c is, I can write my complete equation. So my complete equation will be given by v is equal to 12t squared minus 14t plus 5. right? And this equation for velocity, it will satisfy the given conditions. Awesome. Next question. Using your answer in B part 1, find an expression for the displacement of the particle given that when time is 1, the displacement is 10 meters. It's a question just like the one above, right? So we found in the previous part that velocity is 12t squared minus 14t plus 5. Now it is important to understand that velocity, it's just a fancy way of saying the change in displacement over the change in time. So velocity can be given as ds over dt, right? So that is what velocity can also be written as. And since I want to find my displacement, I want to find an equation for displacement, I would have to integrate both sides. So I'll integrate ds over dt with respect to time. Right, and since I'm integrating with respect to time, I have to put the dt. Right? The dt and the dt would cancel off, and if I integrate ds, I'll just get displacement, so that checks out as well. Right, and again, when we're integrating, we're adding 1 to the power, and then dividing by that new number. So 1 plus 2 is 3, so 12t to the power 3, all over 3, minus 14t, this is understood to be t to the power 1, so I'll add 1 to that, so I'll get 2, then I divide by 2, right, and I'll slap on a t to the 5. And since it's an indefinite integral, I put on I can't forget the plus c. Now in the question, they gave me conditions, so I have to use the conditions to find for c. Like I say, think of c as a condition you have to find for. Alright guys? Before I do anything, let me just simplify. So 3 into 12 is 4. So I will end up with 4t cubed. 2 into 14 is 7. I get minus 7t squared plus 5t plus c. Now the condition is that when the time is 1 second, my displacement is 10 meters. So when time is 1, my displacement is 10 meters. So anywhere I see t, I replace it for 1. Anywhere I see s, I replace it for 10. So let me do that here. So 10 would be equal to 4 by 1 cubed minus 7 by 1 squared plus 5 by 1 plus c. Now guys, anything by 1 is itself, so 4 by 1 is just 4, minus 7 by 1 is minus 7, 5 by 1 is 5 plus c, right? 4 minus 7 plus 5, you can plug that into the calculator straight, you will get 2. So 10 is equal to 2 plus c, right? So if I want to find for c, I'll have to move across the 2. So I will end up with 10 minus 2 is equal to c. So c will be equal to 8 because 10 minus 2 is 8. That being said, I could now write my final equation for displacement. So my displacement is equal to 4t cubed minus 7t squared plus 5t plus 8. And that is my equation for displacement that satisfies these given conditions. And that's how you handle a question like this. Last question. Let me check it out. The gradient function of the curve C is given by 7 minus 2x. So immediately, let me underline that. They're saying that the gradient function. Gradient is just a fancy word for dy dx. It's the other way around actually. Dy dx is all more complicated than gradient. Yeah. So gradient, that means the change in y over the change in x, and that's what gradient means. So dy dx is equal to 7 minus 2x according to the information given. and they're saying that the curve passes through the point 3,8. So you could think of that like a condition, because your curve had to pass through 3,8. So 3,8, that means that x is equal to 3. When x is equal to 3, y is equal to 8. And they want me to find the equation of the curve. If we have to find the equation of a curve, they want us to find for y. So in other words, we have to integrate both sides. So I'm going to integrate dy dx with respect to x, because x is my unknown. Right? So if I integrate dy dx, dx and dx cancel off, and if I integrate dy, I'll get back y. Awesome. If I integrate 7, I will get 7x. If I integrate minus 2x, this is understood to be to the power 1. I will add on a 1 to that, so I'll get 2. Then I will divide by 2, and I will not forget to put the plus c, because this is an indefinite integral. Right, let me just simplify before I find for c. I will end up with 7x. The 2 and the 2 would cancel off, so that leaves me with minus x squared plus c. Now they gave me a condition. They said that the curve has to pass through 3,8. So when x is equal to 3, when x is equal to 3, y is equal to 8. Awesome. So wherever I see y, swap it out for 8. Wherever I see x, swap it out for 3. So let me do that real quick. So 8 is equal to 7 by 3 minus 3 squared plus c. So 7 by 3, that's 21. 3 squared is 9, so minus 9 plus c. 21 minus 9, that is 12. Alright, let me just confirm that. The trust issues are real, guys. Yeah, and if I want to find for c, I would have to move across the 12. So 8 minus 12 is equal to c. So c would be equal to minus 4. So my final equation for y would be equal to 7x minus x squared minus 4. That's it there. That is what y is equal to. Bam. Right, so all of these questions was pure integration. Right? Right. So that's it for question 5. Right, that's it there. We are on the last section now. So question 6a. The heights of 35 children at a nursery were recorded to the nearest centimeter. The data is shown below. Wait. Just by looking at that, I could see that it didn't help us out. All the data is just spread out. It's not in ascending order. But that's okay. They want us to show the data above as a stem and leaf diagram. So a stem and leaf diagram consists of tens and ones. Let me just explain that concept real quick. Imagine I had 65, right? 65, what that means is that I have 6 tens, right? I have 6 tens to get the 60, and I have 5 ones to get the 5. Another example is 117. What that means is I have 11 tens, and the 11 tens is what I would use to get the 110, right? So I'm going to draw 11 tens, right? But you'd have 11 tens and 7 ones, and that would make up 117. So that's basically the concept here. So a stem and leaf diagram consists of the tens and the ones. So your stem is your tens, and your leaf, that's your ones. So the smallest tens I have is in the 60 category. So I'm gonna put on a 6 here. We also have 7. After 7 we have 8. After 8 we have 9. After 9 we have 10. And after 10 we also have 11. Alright, so let's get cracking. So the smallest one's value we could have for 60 is 0. I'm not really seeing 0. So let me just I'm gonna put a different color by the different tens. So 60. I have 61 over there. I have 62 over here. I have 65 over here. I have 67 over here. And I have 62 over here. I pray to God I didn't miss any. I mean, I'm blind already, I wear glasses, but hoping to God I didn't miss any. So that is like 5. Right, so we had to account for 5. So the smallest value is 1. Right, 1. And after 1, we have 2 2s. After that, we have 5. And after that, we have 7. Cool. Next up, we're looking at the 70s. So 79, 70, 75, 76, 79, 71. Okay. And then you missed that 78 there. 74, 79. So we have plenty 70s to account for. So the 70s, it starts at 70. So the smallest ones we have is 0. Right? After the 0, we have 1. After the 1, we have 4. After the 4, we have 5. After the 5, we have 6. After the 6, it seems that we have 8. And then we have 1, 2, 3 9s. Okay. That was exhausting. Let me look at 80s now. So I have 83 here. I have 80 over here. 84. 86. 81. Alright, that seems to be all the 80s. So again, the smallest ones there is 0. 0. After 0, I have 1. After 1, I have 3. After 3, I have 4. After 4, I have 6. Okay, let's move on. Let me look at the 90s now. I have 90 over here. I have 95 over here. 92. I have 92 as well. I have 94 here. I have 99. And I have 92. Cool. So how much 90s do I have altogether? 1, 2, 3, 4, 5, 6, 7. I have 7. And the smallest one's value there is 0 again. So 0. After 0, I have 2. Right, I have 2 here. I have a 2 here. I have a 2 here as well. So that's 3 2s. After that, I have 94, so that's 4. After the 4, I have 5. After the 5, I have 9, it would seem. Right? Yeah. This is the most diabolical question in this whole exam. I swear to God. Alright, so let me check out question 10. Sorry, not question 10. Let me check how much 10s it have now. Like 10 10s. So I have one over here, Right. So the smallest ones values for the hundreds is, that looks like, I would say 3. After 3 we have 2 8s, and then we have 2 9s, right? And on the last one, the 11s. So that's just the ones remaining. So that's just over here. All right. So we have 111. We have 118, 115, 116. Is that it? It would seem so. So the smallest one here is 1. After 1 we have 5. After 5 we have 6. After that we have 8. So 1, 5, 6, 8. Right. Time for the big moment of truth. We're gonna count now, and hopefully we get to the 5. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31, 32, 33, 34, 35. Thank God. Thank God that that's the end of that. Right? So from the 7-leaf diagram, determine the value of the median. If I want to figure out median, we're referring to Q2. The position of Q2 will be a half n plus 1, where n is the total number. So it had 35 kids in the nursery, so 35 plus 1 is 36, a half at 36, that is 18. So my median would be my 18th term. Oh wait, I forgot one thing. You have to put a key or legend, right? In your 7-leaf diagram, you have to put a key or legend. So key, my key would be, you can pick any one, but I'm gonna pick 11/6. That is equal to 116, right? So my 18th term will be over here, right? So my 18th term is 84. So Q2 is equal to 84, right? If I want to figure out my lower quartile, that is a quarter of n plus 1. Like I said, you have 35 kids, so that'll be 36. So a quarter of 36, that's my 9th term. Right, so we're looking for my 9th term. My 9th term, that is 75. Right, and the upper quartile, oh wait, I made a small mistake here, guys. The lower quartile is not Q3. I don't know where I get that from. The lower quartile is Q1, right? The upper quartile is Q3, right? So Q3, that will be equal to 3/4 of n plus 1, which is 36. 4 into 36 is 9, 9 by 3 is 27. So I'm looking for my 27th term, right? So Q3 is my 27th term. My 27th term would be 103, right? Bam. So part 3. At another nearby nursery, the heights of the children of the same age were recorded. The median height was 79, and the interquartile range was 24. Compare the characteristics of the two groups of children at the two nurseries and describe one distinct observation about the distributions. So they want me to compare the characteristics. So I could easily compare the medians. The median in the first nursery was 84. Compared to 79 in the other nursery, and that would suggest a difference of 5. Right, and let's find the interquartile range real quick. For this nursery over here, the interquartile range is given by Q3 minus Q1. So that will be equal to 103 minus Q1, which is 75. So 103 minus 75. So that will be equal to 28. Right? The interquartile range in the first nursery was 28 centimeters compared to 24 centimeters in the other nursery. Right, and that would mean we have a difference of 4, right? And they wanted me to state one distinct observation about the distributions. So let me talk about range, right? IQR. Now we don't have the lowest and the highest data point for the other nursery, so I can't really compare the whole ranges, right? But I can compare the interquartile ranges. What the interquartile range or any range does, it tells us the disparity in the lowest and the highest. So the interquartile range in this nursery was 24, whereas the interquartile range in the first one was 28. Since the interquartile range in the first nursery was bigger, it suggests that there's a bigger disparity in heights in the first nursery. Right, so I could write that down. In the first nursery, the heights of the children vary more significantly than the heights of the children in the other nursery. Right, so again, the range on average, it tells us the disparity or the difference between the highest value and the lowest value. So if in the first nursery our interquartile range was greater, it suggested that there was a greater difference between the Q3 and the Q1, basically the lowest and the highest for those respective ranges, meaning that there's more diversity when it comes to the heights in the first nursery. Right. So that's it for this question. I think it was a lot of working for 2 marks though. This question over here, let's check it out. A bag contains 6 red marbles and 5 black marbles. During 2 rounds of a marble game, a student is required to randomly draw 1 marble without replacement. Let's underline that one time. For each round, construct a probability tree diagram to represent this information. So let me analyze what's going on. You have a bag of 6 red marbles and 5 black marbles. Every time you take out a marble, you're not putting it back. So the sample space keeps decreasing by 1. Right, so a bag contains 6 red marbles and 5 black marbles. Right, so in the first round, so let me check out what was going on in the first round. So let me just draw a bag real quick. I'm an artist, guys. Trust. I'm a very skilled artist. Like Trinidad's finest. Yeah. Can't touch that. So we have 6 red marbles. And you have 5 black marbles. So in the first round, when the person picks, they can either get a red or a black marble, and the sample space is full because that's the first round. So this branch over here is the probability of getting a black marble, and this over here is the probability of getting a red marble. I'm gonna put it in red. Awesome. So since the person didn't pick out a marble as yet, the sample space is the original amount. No marbles were taken as yet. So originally we had 5 black marbles, and the total number of marbles would have been 11. Right? And that's the first round because the person did not take any marbles as yet, so we still have the original amount. Right? And originally it had 6 red marbles and it had 11 marbles to choose from. So you have a 6 in 11 chance of getting a red. Let me just say in the second round, you take a black marble. So if you were to pick a black marble in the second round, you would have 1 less black marble to pick, and you would have the sample space would drop by 1. So this is what would happen. So if over here you were to pick a black marble, now the probability of getting a black marble, it would decrease because you take out 1. So that will be 4 over 10. Because if you, like I say, if you take a black marble out of the bag, your sample space decreasing by 1. So that's how I get the 10. And if you take out a black marble and you're not replacing it, that means only 4 will remain again. Right? Let me just say you don't get a black marble, you get a red marble. Since you didn't get a red marble in the first chance, you still have the original amount of red marbles, but your sample space still would have decreased by 1 because you already take a marble already. Right? So 3, well that'll be 6 because you didn't take a red marble as yet. And the sample space could be 10, so that'll be 6 over 10. Right? When I finish with the question, I will show you guys a little trick to know if you're going correct. Alright. Let's just say you got a red marble. So if you get a red marble now, it's a different story. If you get a red marble, that means you have to take out a red marble. So now you have 5 red marbles to choose from, but you still have the 5 black marbles to choose from because you didn't take any black marbles. So the probability of getting a black marble, granted that you take a red marble out, that'll be 5 over 10. Reason I say 5 over 10, that's because you draw a marble already, you draw a red one, and because you take a marble out and you didn't replace it, sample space dropped by 1, you didn't get a black marble, so you'd still have 5 black marbles to choose from. Let me just say you pull another red. If you pull another red, you have to keep in mind you already take a red over here. So since you already pull out a red, you have 1 less red to choose from. So now you have 5 over 10 to choose from. Right, so you have 5 red marbles now because you had taken 1 out previously over here. right? And your sample space will decrease by 1. So 5 over 10. And that's the probability tree diagram there. Let me just erase my beautiful drawing. Right, so that's the answer there. Right, admire the art. It's very wonderful. So let me speak about this magical trick I was gonna show you guys. At any point in time, the probability when you add it up, it's supposed to be 1. So if I add up 5 over 11 and 6 over 11, I will get 1. If I add up 4 over 10 and 6 over 10, I will get 1. If I add up 5 over 10 and 5 over 10, I will get 1. So the sum of probabilities along any two branches should be 1. Right? Using the answer in D part 1, find the probability that the marbles drawn are all the same color. So it had two ways this could happen. You could get a black and a black, or you could get a red and a red. So my students could know that anytime you see or means to add. I'll give you a simple explanation why. Imagine you had to go out with your friend and you say, yeah, my uncle could drop me, my aunt could drop me, or my brother could drop me, or my other aunt could drop me, or my mom could drop me, or my dad could drop me. You understand? If it's or, that means the likelihood of you going increases. Right? So or means to add. That means you're increasing your probabilities. If it's and now, is pressure. Let me give you an example. Imagine I ask you what is the probability of you getting 100 in the add maths test. Right? And what if I add on your friend and ask you what is the probability of you and your friend getting 100? Now that kind of hard because you can't control what your friend do and your friend can't control what you do. So anytime is and, you have to multiply because your probability decreases. Right? Probability is a fraction, and anytime you multiply a fraction by a fraction, the final answer decreases. Take for instance a half by a half. A half by a half is a quarter. A quarter is smaller than a half. Right? So anytime you see or, it's add. Anytime you see and, you multiply. So if I want to figure out the probability of getting the same color, well, I could either get a black and a black. I don't know why I'm drawing that in red. Oh well. You can get a black and a black. Alright. Or you can get a red and a red. Let me use the fancy symbols. So the probability of getting a black and a black, or probability of getting a red and a red. Like I told you guys, if it's and, you're multiplying. So the probability of getting a black in the first round is 5 over 11. So I will say 5 over 11, right, multiply by 4 over 10, right, because this is the probability of getting a black in the first round and getting a black in the second round. So that will be 5 over 11 by 4 over 10. Right? Put that in brackets. And since I could also get 2 red marbles, I had to take into consideration that. So that added into my likelihood. So I have to add it. So again, I red and I red. The probability of getting a red in the first round is 6 over 11. And getting it in the second round will be 5 over 10. So that's 6 over 11 by 5 over 10. 6 over 11 by 5 over 10. Right? You're going to end up with 5 by 4 is 20. 11 by 10. That is 11 tens. Go off the previous question. And that'll be 110. Plus 6 by 5 is 30. Right? 11 by 10, that's 110. You have the same denominator. So you could add on top. So 20 plus 30 is 50. 50 over 110. Right? 5 over 11. Now I have some trust issues, so I'm just going to check if that's correct. So 5 over 11. 5 over 11 by 4 over 10 plus 6 over 11 by 5 over 10. Let me see. Yep, that is correct. Right, so again, just some general advice for students who might be looking at this video to study. Anytime we do a probability tree and they say without replacement, just keep in mind that means you're taking out something and then not replacing it. So the next rounds it would decrease by 1. Another thing to keep in mind is that the sum of two branches must always be 1 because 1 is the max probability. Another thing to keep in mind, or means add, because if I say or, that means my likelihood increasing, and if I had to include 2 or more people or 2 or more events that had happened at the same time, that's very low. So that's and is multiply. Right? Again, imagine if I ask you what's the probability of it raining in Trinidad, that's probably high. But then if I ask you what's the probability of it raining in Trinidad and the Sahara Desert, that kind of slim now, eh? So and is multiplying probabilities. When you multiply fractions, the final answer is small. When you add fractions, you get a bigger fraction. So keep that in mind. Let me check out this question here. So given two events, A and B, probability of A union B is equal to 0.7, probability of A is equal to 0.3, and probability of B prime is 0.6. Calculate the probability of A intersect B. Okay, before I do anything, if the probability of not B is 0.6, that means the probability of B has to be 0.4, because at all times the probability must add up to 1. So now I could utilize my formula for non-mutually exclusive events. So the probability of A union B is equal to the probability of A plus the probability of B minus the probability of A intersect B. So the probability of A union B is 0.7, the probability of A is 0.3, the probability of B is 0.4, right, minus the probability of A intersect B. Right, so 0.7 is equal to, well, 0.3 plus 0.4, that is also 0.7, right? And I want to find for A intersect B, so I will move across the 0.7. I will end up with 0.7 minus 0.7 is equal to minus the probability of A intersect B. Let me just make some space here. Right, minus the probability of A intersect B. Right, so 0.7 minus 0.7, that's 0. So 0 is equal to minus the probability of A intersect B. Right, if I want to find for the probability of A intersect B, I would have to multiply by minus 1 on both sides. It wouldn't make a difference, right? Because 0 by minus 1 is still 0. So simply put, the probability of A intersect B is 0. Now if the probability of A intersect B is 0, that suggests that it's a disjoint set, meaning that it can happen at the same time. Right? So this is what the set would look like. It would suggest that the two events are mutually exclusive. They could never happen at the same time. The probability of that and that happening is very unlikely. Let me give you an example. Probability of it having potholes in Trinidad. Right? And the probability of it being fixed. Yeah, I don't see that happening. Right? So them two events can happen at the same time. And the fancy word for that is mutually exclusive events. Alright guys? Let me just neaten up this and fancy it up. It's a real nice example. Wait. I can't draw a rectangle now. I'm gonna fix up that. Right. Yeah, so this over here is the probability of it having potholes in T and T, right? And this over here is the probability of it being fixed. Never happen. Yeah. And if two events can happen at the same time, like I said, we refer to them as mutually exclusive events. Right? So, let me just recap this question one more time. So they gave me a probability of A union B, they gave me the probability of A, and they gave me a probability of B complement, and that was 0.6. So, if B complement is 0.6, that would mean that probability of B happening is 0.4, because the max probability is 1. From there, I have to use the formula for non-mutually exclusive events to find for what probability of A intersect B is. And well, we found it to be 0, which suggests that we have mutually exclusive events. So if you guys reached this far, I want you to drop Mathvybes in the chat and give me any feedback, right? Because it's my first video and I'm still new to all of this. Just a reminder, I do have lessons. Feel free to contact me via this number if you're interested in joining my Maths, Physics and Maths classes. Alright, so I hope that was good. Take care guys and best of luck studying. Later.